look at writing electron configurations for ions. So going back as a review, remember every element in group 1 has a positive 1 charge. Every element in group 2 has a positive 2 charge. Every element in group 3 has a positive 3, plus or minus 4. Remember negatives up here, positives down at the bottom for your metals. Every element in group 5, negative 3, group 6, negative 2, group 7, negative 1, and group 8, 0. So, making sure we understand why these ions are forming. So when we look at fluorine, fluorine is a halogen, and it has a charge of negative 1. Lithium is an alkaline metal, is a positive 1. So making sure that you remember that if it's a negative charge, it's a non-metal, and non-metals form anions. Metals form cations. And remember that this is done by gaining electrons here, losing electrons. So metals lose electrons to look like the noble gas that comes before it. Non-metals will gain electrons to look like the noble gas that comes after it. So let's take a look. What noble gas comes before lithium? Helium. So lithium will lose electrons to look like helium. Take a look at nitrogen. Nitrogen is a non-metal, so non-metals will gain electrons to look like the noble gas that comes after it. What noble gas comes after nitrogen? It's neon. Take a look at aluminum. Aluminum is a metal. Aluminum has a charge of positive 3. What noble gas comes before aluminum? Yes, it is neon. Taking a look at bromine. Bromine is a non-metal. What noble gas comes after bromine? Krypton. So remember, for non-metals, it's the noble gas that comes after it. That's sloppy. Let me fix that. All right. For non-metals, it's the noble gas that comes after it. And for metals, it's the noble gas that comes before it. All right. So when you write the electron configuration, let's write the electron configuration for helium. Helium has an electron configuration of 1s2. Lithium atom has an electron configuration of 1s2, 2s1. Now lithium forms a positive 1 ion. That means that it loses 1 electron. This electron is lost from the valence shell. So when we write the electron configuration for lithium ion, it's going to be 1s2. And what noble gas does that look like? It looks like helium. Let's take a look at fluorine. Fluorine is going to look like the noble gas, or fluorine ion is going to look like the noble gas that comes after it. What noble gas comes after fluorine? It is neon. So first, let's write the electron configuration for neon. Neon's electron configuration is 1s2, 2s2, 2p6, and that is the electron configuration for neon, 1s2, 2s2, 2p6. So first, I'm going to write the electron configuration for fluorine. Fluorine atom has an electron configuration of 1s2, 2s2, and 2p5. In order for fluorine to look like neon, it has to go from a p5 to a p6. And remember, fluorine has a charge of -1, so that -1 means it gains 1 electron. So it's going to gain 1 electron to look like neon, so when it gains that electron, Fluorine ion electron configuration will be 1s2, 2s2, and 2p6. Again, fluoride gains an electron. That -1 means it gains 1 electron. So it goes from fluorine atom to fluorine ion by gaining 1 electron. Let's look at another example. All right, so let's take a look at oxygen. Oxygen atom and oxygen ion. Well, first let's write out the electron configuration for oxygen atom. All right, that's the electron configuration for oxygen atom. Now, oxygen ion has a charge of -2 because every element in group 6 has a -2 charge. So that means it gains 2 electrons. So if this is going to gain 2 electrons, which noble gas should it look like? It should look like neon because anions form ions so that when they gain electrons, they look like the noble gas that comes after it. So let's first write the electron configuration for oxygen ion. So it becomes 1s2, 2s2. So it's going from 2p4. If it gains 2 electrons, that becomes 2p6. 6 plus 2 equals 8. 8 plus 2 equals 10. And that's the number of electrons for neon. Let's write the electron configuration for neon just to check ourselves. So it becomes 1s2, 2s2, and 2p6. So oxygen ion and neon, their electron configurations are the same. If you take a look at calcium, which noble gas will calcium look like once it forms an ion? Remember, calcium forms a +2 ion, so that means it loses 2 electrons. Which noble gas will calcium look like? It will look like argon. It will assume the configuration of argon because it loses 2 electrons. It goes from 20 electrons as an atom to 18 electrons as an ion. Okay, let's try another one. What noble gas will sulfur ion look like? Sulfide. This is in group 6, so it has a -2 charge. What noble gas will sulfide look like? It will look like argon because this is a noble gas that comes after it. It will gain 2 electrons to look like argon. If we take a look at phosphorus, every element in group 5 has a charge of -3. And since it is an anion, it will gain electrons to look like the noble gas that comes after it. What noble gas will phosphorus look like? The electron configuration for phosphorus ion will be the same as argon, all right? So remember, cations, in summary, cations lose electrons, and anions will gain electrons. Kind of hard to see what this says. All right, that's the end of all the videos for electron configurations. Make sure you watch these videos as often as you need.